ओके, चलो कीप रीडिंग. काइनेमेटिक्स ऑफ सर्कुलर मोशन. सो हम लोग क्या क्या पढ़ने वाला है? काइनेमेटिक्स वी विल स्टडी, डायनेमिक्स विल स्टडी, एंड डायनेमिक्स में वन ऑफ द टॉपिक इज वर्टिकल सर्कुलर मोशन आल्सो वी विल स्टडी. पूरा सर्कुलर मोशन विल बी डन. एंड ठीक है, वी विल सी दिस काइनेमेटिक्स का.
Sir,
सो काइनेमेटिक्स,
will we be able to finish
सी
circular motion by
स्टार्टिंग ओनली, फिनिशिंग बोलते हैं. मैं क्या करूं यार? करो पहले, देखते हैं आपका फास्टनेस का, देखेंगे इसका कैसे बोल के. ओके, काइनेमेटिक्स ऑफ सर्कुलर मोशन में वी हैव टू स्टडी सम वेरिएबल्स. आपको लीनियर नॉर्मल काइनेमेटिक्स में वी स्टडीड अबाउट व्हाट आर द वेरिएबल्स. वी स्टडीड काइनेमेटिक्स में, वी स्टडीड अबाउट द डिस्प्लेसमेंट, वेलोसिटी, एक्सेलरेशन, लाइक दैट वी स्टडीड, राइट? सो हियर एंगुलर सर्कुलर मोशन में एंगुलर वाला आएगा, एंगुलर डिस्प्लेसमेंट, एंगुलर वेलोसिटी, एंगुलर एक्सेलरेशन. वी विल सी द वेरिएबल्स. देखो, लीनियर का displacement, velocity, acceleration, time period, and frequency we studied, right? Same way here in angular में angular displacement को we call as theta. We represent angular displacement as theta. These symbols if you know, then only it will be easy for you. And we in linear में angular में omega बोलते हैं, omega. And acceleration is a, and angular में alpha, alpha. एंड टाइम पीरियड टी को टी बोलते हैं, एंड फ्रीक्वेंसी इसको ओमेगा बोलते हैं, एंगुलर फ्रीक्वेंसी बोलते हैं. ओके, लिख लो. द डिफरेंसेस यू हैव टू नो. एस थीटा, वी ओमेगा, ए अल्फा, टाइम पीरियड टी, एंड फ्रीक्वेंसी ओमेगा. नो, अगर ये यू नो वी स्टडी दिस वेरिएबल्स मींस आपको काइनेमेटिक्स विल बी डन. काइनेमेटिक्स का हो जाएगा इफ यू स्टडी दिस वन. Now, first variable we will going to study is angular displacement, theta. Okay, displacement मालूम है, angular displacement का, and we will see the relation between linear and angular में बहुत काम आएगा, relationship बहुत काम आएगा. मतलब they'll give in linear wise में they'll tell to find angular, और angular wise में they'll tell to find angular linear displacement. Like that we have to know the relationship also. Okay, चलो. So first one is
So the last one's also omega and velocity is also omega.
velocity is omega. This is angular frequency बोलते हैं. Symbol is same. Angular velocity, angular frequency symbol is same. So circular motion में circular का कहानी only we have to see. In that में variables, these all variables will be coming.
Yeah, sir, done. So what's the last one? F by N.
F or N. Some books में they will put N. Some books में they will put F.
What is that? Force only, right?
Frequency. F is called frequency. And T is called as time period.
Time period, yeah.
Time period.
Yeah, okay, got it.
Okay. Chalo. Now first one we'll study about angular displacement theta. Angular displacement in a circular motion point of view, angular displacement is what? The angle turned by the radius vector in a given interval of time is called angular displacement. कितना angle घूमा in a circular motion में. So this is a circular motion, center वो, and this is a radius vector. Suppose initially the point P is here. The point P after certain time t के बाद it came to here मान लो P dash. This is a radius vector, right? So ये particle, this particle कितना angle घूमा, this angle को we call as angular displacement. Theta. Theta is angular displacement. Okay. So from here if I see the particle is going circular motion में, if this is a straight path first particle है, मैं ऊपर जा रहा हूँ, ऊपर जाने से मैं ऊपर देखा ना, मेरा का एक कितना angle घूमा, that is called angular displacement. Theta. And angular displacement is a vector quantity or scalar quantity? Displacement है ना, vector quantity. Okay. चलो इसका यूनिट्स भी देखेंगे वगैरह. कब बेटा?
1 second. Yeah, done. So where is Ramesh? Draw the figure.
Pranav writing, right? Yeah.
So what is around
Yes,
P
sir.
prime?
No. P is a point. P dash. Bola. मतलब new position of the particle. Okay.
That's what done.
No. No. SI unit is radians. Always we'll measure angular displacement in radians. SI unit is radians. Okay. And it is a vector quantity. इसका direction is given by right hand thumb rule. Right hand thumb rule से direction है. So direction, which direction the particle? देखो, particle is P here. The particle came up to here, P dash, right? कितना angle घुमा? So देखो, angular displacement in 2 dimension we are showing like this. But इसका direction कैसा आएगा मालूम है? Right hand thumb rule से we can find. कैसा? देखो, fingers are directed along the motion of the particle. The particle is moving like this. इधर से. So we have to curl the fingers in the direction of the motion of the particle, and thumb indicates the direction of the angular displacement. So angular displacement is always along the axis. Along the axis. Okay. So curl the fingers in the direction of the particle. The thumb indicates the direction of the angular displacement. If the particle is rotating in the clockwise, curl the fingers in the direction of the motion of the particle, and thumb indicates the direction of the angular displacement. So it will be always along the axis only. That's why इसको हम लोग axial vector बोलते हैं. कौन सा वेक्टर? Axial vector. Axis के along है. Okay. And इसका dimensions can you tell me? इसका क्या होगा? Dimensions? Tell me. Dimensions इसका.
1 second. T minus 1.
Sir, M0, L0, T0.
No dimensions. Radiance angle का no dimensions. So this is a rare quantity which has a unit but no dimensions. But not dimensions is nothing but angular displacement. Example में देगा which a dash quantity will have a unit but no dimensions means this one angular displacement. Okay. Next. It is a dimensionless quantity. So M0, L0, T0. If we calculate theta in anti-clockwise sense, we consider it as positive. When measured in clockwise sense, it is negative. कभी भी anti-clockwise measurement जो भी है वो positive डालो. अगर clockwise sense में घूमेगा, we have to take the angle as negative. Suppose initially मान लो it went to 120 degrees, again came back 60 degrees. So what will be the resultant displacement means? So 120 plus minus 60. So 60 degrees is the answer. So net displacement is anti-clockwise positive, clockwise negative. देख लो. So first physical quantity we're learning angular displacement. Okay, finished?
Yeah, sir.
Chalo. Now relation between linear and angular. I told right linear and angular का always सभी में relationship is there. वो relationship क्या है? Very famous relationship है. याद है
It's
किसको?
equal to R theta.
Yes. So R particle P है and P dash it came right. This is theta, right? So here linear displacement is where particle जो walking कर रहे हैं, that is called linear displacement. This is linear displacement, right? S is the linear displacement. Now we know the relationship between displacement, radius and theta. When displacement is very small, so what is the relationship? Arc length, radius and theta. That is nothing but क्या आएगा? S equal to R theta. S याद है ना? Arc length is equal to this radius into theta. And in this way, theta should be in radians. Then only we can use this relationship. Theta should be in radians. Now vector relation is there. Vector relation, both these are vectors, right? So vector का relation क्या आएगा? आपको ये उल्टा जैसा हो जाएगा. देखो theta cross r. Theta cross r is the displacement vector. देखो S vector is equal to theta cross r. So first quantity understood, right? Finished? Yes, angular displacement ka done, right? Now second one is angular velocity, omega. Now easy, right? You compare always with velocity. Velocity से compare किया तो formulas पूरा आ जाएगा. Circular motion, you know, circular motion कितना perfect हो जाएगा? System of particle rotational motion, which I told 11th class में toughest chapter. That उसमें आपको easy हो जाएगा. Circular motion should be very perfect. Okay. Angular velocity. Simply we can define velocity is what? Rate of change of displacement. इसका velocity. इसको क्या बोलते हैं? Rate of change of angular displacement is called as angular velocity. So लिखो. The time rate of change of angular displacement of a particle is called as angular velocity. So omega is कितना angle घुमा upon time. This is a basic definition. कितना angle घुमा upon time. Displacement by time is called. इसको मैं compare करो. Displacement by time, right? Same thing. Omega is nothing but theta by t. And इसमें भी same कहानी है. A भी वेक्टर क्वांटिटी है. इसका यूनिट्स आर रेडियंस पर सेकंड. रेडियंस पर सेकंड देखो, रेडियंस पर सेकंड इज अ फॉर्मूला. ऐसा यूनिट्स, राइट? नेक्स्ट, इट इज अ वेक्टर क्वांटिटी. एंड नाउ इसका डायमेंशंस बोल सकते हो बाय t इज, राइट? सो इट इज डायमेंशंस इज t पावर -1, m0 l0 t पावर -1. So direction of angular velocity is given by same thing, right hand thumb rule. A भी along the axis रहेगा, A भी axial vector है. Okay, so इसका angular velocity का direction is always along the axis only. Right hand thumb rule से already we wrote right hand thumb rule, right? वो वाला, and it is a axial vector. Done ना?
So 1 second. So this dimensions will be t-1 only, right?
Yeah, t-1. So dimensions क्या होगा? m power 0, l power 0, t power -1. Okay. So now we have two types of angular velocities. We know already, average angular velocity and दूसरा instantaneous angular velocity, right? So देखो, omega average formula is delta theta by delta t, right? We know this one, right? V is equal to average velocity का formula क्या होगा? Delta s by delta t. Same thing. Omega average will be delta theta by delta t. You should compare with the always linear से compare करने का. And incidence velocity will be d theta by dt. And v incidence कितना था, which we studied in kinematics में? ds by dt, rate of change of displacement. देखो, कंपैरिजन से पूरा आ जाएगा फॉर्मूला. तो मतलब काइनेमेटिक्स में जो भी किया है, they will give in terms of omega theta. We have to find the value of for this one. Easy, right? They'll give in terms of theta like this. Theta is equal to t square plus 2t plus 3. He will tell to find the angular velocity. So what to do? Simply d theta by dt. So differentiation of t square is 2t plus 2 will be coming outside. Differentiation of t is 1. So it is 2t plus 1 is the answer. If they ask at particular second में, you substitute t, you'll get the answer. Same methods, right? समझ में आ रहा?
So 1 second.
Yes.
Yeah, got it. Yeah, so done.
Yeah, चलो. Now देखो, when a body makes n revolutions in t seconds, चक्कर घूम रहा है, चिक 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 बोल के n revolutions मार रहा है in t seconds, then average angular velocity will be, what is that angle, total angular displacement is how much? one complete revolution is 2 pi radians, right? So n revolutions will be 2 pi n revolutions displacement by time. This is answer, right? 2 pi n by t. One revolution is 2 pi. N revolutions will be 2 pi n. That is the total displacement upon time. Is nothing but angular velocity.
Yeah, sir, done.
Okay, t is the total time, right? कितना time में घुमा है, that is the time. Okay. चलो करो आंसर.
I got my answer.
How much?
I got 2 pi n1 minus n2 by t1 plus t2.
2 pi n1 minus
That's the
n2
same
by
answer.
T1
T1
plus
plus
yes.
T2.
Yes, correct. Because total angular displacement total time taken, right? ये एंटी क्लॉकवाइज को पॉजिटिव ले लो एंड क्लॉकवाइज का नेगेटिव ले लो. सो 2 pi n1 minus 2 pi n2 by t1 plus t2. 2 pi कॉमन लेते हैं. दिस आंसर आया. ये करो स्मॉल थिंग. Angular displacement is given in terms of time. Find the angular velocity. Right answer you can get, right?
Sir, 2CT minus B.
2ct minus p is the answer. Okay, differentiate करने right? d theta by dt. Yeah. चलो. Now relation between linear velocity and angular velocity. Compulsory relationship लेना पड़ेगा. Okay. So relationship क्या है? What is the relationship? Famous relationship we learned, right? What is the formula? V is equal to same displacement का कैसा है ऐसे ही लेने का. Tell me. याद है? Suppose मान लो the particle is displacement is small ds and radius is r and displacement is d theta. ये linear displacement है, ये angular displacement है. Okay. And we know the relationship. क्या है? Tell me. ds is equal to r into d theta. Right? आपको डिस्प्लेसमेंट से वेलोसिटी कैसे आएगा? डिफरेंशिएट. सो ds by dt is equal to r is constant d theta by dt. So what is ds by dt? Rate of change of displacement is called velocity. So with linear displacement, right? Linear displacement का linear velocity आएगा. V is equal to r into rate of change of angular displacement is nothing but omega. So V is equal to r omega is a very famous relationship. V is equal to r omega is a formula. Linear and so याद रखो one small thing I'll tell you. Linear and angular में always r आएगा. So V equal to r omega. Linear and angular में always r आएगा. So S equal to r theta. S equal to r theta. So r will be coming in linear and angular के बीच में. R is radius vector. And vector relation क्या होगा इसका? Vector relation will be उल्टा. क्या होगा? Omega cross r will be vector relationship, right? So vector form में omega cross r is a form. लिखो. So V equal to r omega is relationship. Next करो. नो करो देखते हैं. जे में क्वेश्चन करो. देखते हैं will do. As shown in figure, a particle is moving with a constant speed. पार्टिकल इधर से स्टार्ट हो रहा है, जूम जूम बोल कांस्टेंट स्पीड में जा रहा है, कितना, दैट इज 5 मीटर्स पर सेकंड से जा रहा है, 5 मीटर्स पर सेकंड से जा रहा है. ओके, कंसीडरिंग मोशन फ्रॉम ए टू बी, द मैग्नीट्यूड ऑफ एवरेज वेलोसिटी, नॉर्मल वेलोसिटी अमाउंट, एवरेज वेलोसिटी, नॉट एंगुलर वेलोसिटी, एवरेज वेलोसिटी करो. I'll give you options, उसके अकॉर्डिंग बोलो. By seeing the units also you can able to identify it. Meters per second is the velocity ka you're asking. 1.5 root 3 and 2 root 3 meters per second. एवरेज वेलोसिटी का फॉर्मूला तो मालूम है आपको. एवरेज वेलोसिटी इज टोटल डिस्प्लेसमेंट बाय टोटल टाइम टेकन. टोटल डिस्प्लेसमेंट बाय टोटल टाइम टेकन.
So but over here, what will be the total time though?
हाँ करो जरा, कैसे करेगा. 120 is given. 120 is what?
1/3 of a revolution.
Theta, right?
Yeah.
Theta is given. Velocity is given, ना? Linear velocity is given. So from that धीरे धीरे टाइम आ जाएगा. देखते ट्राई करो.
So what's the radius?
नहीं दिया.
So then how do we solve it?
R ले लो.
So then R should be there in the answer, no?
Oh,
But some cancel हो जाएगा. Time how much took tell me?
2R square by 3.
2R square by 3. Yeah. Time I'm asking.
Yeah.
No, wrong.
so wait, sir, how do we find displacement? Like if the initial position is A and final position is B.
Anywhere you listen, so in a circular motion में we can
Oh,
find the shortcut.
I got it.
देखते हैं.
Sir, I got pi.
Paya.
Sir, what is this formula? What is that called? Sir,
Displacement याद है कृषि आपको?
vector thingy, what's it called?
Uniform circular motion में the displacement we can find with any angle. I given a shortcut starting में kinematics में.
So what is that formula, sir? A square plus B square.
2R
Sin theta by.
something, 2R sin theta by. देखो, initial point is here, final point is here. This displacement we can find by using the formula 2R sin theta by 2. This is a displacement shortcut formula we learned in the kinematics में. Any point में, any angle में we can find by this formula, right? In uniform circular motion only we can use this one. Okay.
Sir, I got plus 1.5 root 3.
Yes, correct. So 2R sin theta by 2 is the total displacement, total time. Time देखो, क्या कृष्णा 120 is what? Theta should be radians, right? कितना होगा in terms of radians में? 120 is
Sir,
pi
got
by
the
3 is 60 into 2 is 2 pi by 3. Theta मालूम हो गया ना? Velocity is given 5 meters per second. We can find time from this. So कैसा आएगा? पहले ओमेगा फाइंड करो. Omega is what? Angular displacement by time, right? So from this t is equal to theta by omega, and we know the relation between v and omega. V equal to r omega, right? समझ आ रहा है? So देखो v is equal to r omega. r पहले ले लो, बाद में देखेंगे कुछ कैंसिल होगा बोल के. So v is
So
pi
we gave omega now.
by r. Omega is given now. Where?
Oh, wait,
No,
V is
nothing is
given.
given.
Okay, okay, okay.
Velocity is given, normal velocity. Pi by r is equal to omega is given. We got pi by r, right? Omega. Now time आ जाएगा. सबसे थीटा के जगह में 2 pi by 3 by ओमेगा के जगह में pi by 3 या pi by r. तो कितना pi by कैंसिल 2r/3 आया. टाइम आ गया ना 2r/3 इन टर्म्स ऑफ रेडियस में. ये सब करो 2r/3. ना देखो r कैंसिल 2 गेट कैंसिल. ना करो कितना आएगा 3 इंटू ये ऊपर 3 आएगा ना 3 इंटू साइन 120/2 is 60. Sin 60 is √3/2. So it is 3√3/2. हाँ ऐसा क्वेश्चन. बट से वर्कशीट इज गिवन. थोड़ा प्रैक्टिस करेगा तो आ जाएगा. सो लीनियर एंड एंगुलर का बहुत रिलेशन देखो v एंड ओमेगा का रिलेशनशिप यूज करके सॉल्व करना पड़ेगा. ऑप्शन के हिसाब से वी कैन चेक. इधर रेडियस में टर्म्स में नहीं दिया सो कुछ कैंसिल होगा बोल के आपको आइडिया नहीं का. बट 2r/sin θ/2 बहुत इंपॉर्टेंट है. वेन एवर यूनिफॉर्म सर्कुलर मोशन में पार्टिकल इज मूविंग फ्रॉम वन कांस्टेंट वेलोसिटी से जा रहे तो देन ओनली वी कैन यूज दिस फॉर्मूला 2r/sin θ/2. चलो ये करो ये
So I can
ऑप्शंस.
go back once.
Yeah.
Okay, sir.
Yeah. चाहिए मैं क्वेश्चंस ट्राई करो बोलो देन ओनली कैन टेल. A person moved from A to B in circular path. The distance traveled by him is 60 meters. Okay.
Okay, sir,
Then
got
the
it.
magnitude of displacement will be.
So for converting into radians, we just need to divide it by 180, right?
Pi radians is 180 degrees. So you can do whatever you want.
So I got 47.
47. What you
Once.
done?
So they gave distance traveled is 60. So I used uh, perimeter of arc formula.
Okay, good. Now try करो.
Yeah, sir, I got 47. I got like 46.9 something, so I estimate 47.
देखो what is the method? Any method you done? This is a
Yeah, so what I did was first I found the radius,
2
and
or
then
sin theta by 2. How to find radius?
the s equal to r theta. But sir, if you use 2r sin theta by 2, it won't work. So I
But
used the vector product, like vector rule, whatever that. The root of a square plus b square minus 2ab cos theta.
cos theta 135, you know,
Yeah,
90
so
plus
they gave the
5.
question right, minus 0.7.
Okay. From that, A and B, R and R you took, right?
Yeah,
How much
so
you
so
got?
you'll get r root 3.4.
Okay.
Then I used calculator. I got 3.4 as 1.8 something. So
Okay.
1.8 into 80 by pi, you get it as 46.9, so 47.
Very good. Okay. Krisha,
So
we,
no.
देखो, one method is directly find the displacement, means the shortest distance from initial position to final position, right? This distance is nothing but आपको displacement, right? मतलब vector sum you can use a vector का. देखो, this one vector is there, A and B, and the resultant is like this. How to find if the what is the formula parallelogram law, मतलब triangle law use किया तो root of a square plus b square plus 2ab cos theta, right? So here a is r, b is r, and cos theta value also given, right? We can use the formula. We get displacement. Or इसमें भी you can go, but 2r sin theta by 2, right? R कैसा आएगा मालूम है normally? You have to use this formula also sometimes. आपको 10th class का मालूम है? Arc length कैसा आएगा? In areas related circles में done arc length. Theta by 360 into 2 pi r. Okay. So from this arc length is nothing but the distance only. Arc length is AB. AB. From this radius I can find easily. Radius I can find. देखो
So we
AB.
can just use s equal to r theta, no sir, a lot easier.
See, कभी भी S equal to R theta we have to use generally whenever there is a small angle. Radius should be very small. Then only that formula is valid actually. So AB into 360 by 2 pi into theta is equal to R. So R आ जाएगा. And theta by 2. इधर problem क्या है फिर से? देखो 2 into R के जगह में I use AB into 360 by 2 pi into theta into sin theta by 2. Sin theta by 2, how to find now? We don't know 135 by 2 is angle नहीं मालूम ना. So क्या करेंगे इधर आपका मैथ्स है ना, ट्रिग्नोमेट्री यूज कर सकते हैं. What
So
is
cos
the
looks formula.
1 minus cos theta is 2 sin square theta by 2,
Theta by 2 minus
right?
1.
So a sin theta by 2, right? A 2 नीचे भेजा. So 1 minus cos theta by 2 square root उधर गए तो under root is equal to sin theta by 2. So now देखो cos theta, the cos 135 is given, right? 0.7 is substitute किया तो, and all values if you substitute, distance is 60, AB is 60, arc length is nothing but distance traveled, right? 60. So everything value substitute किया तो we'll get the answer. So either you can go for a square plus b square plus 2ab cos theta, or you can go for this method. Arc length का but learn करना पड़ेगा sometimes, useful होगा. So arc length का is formula is always theta by 316 2 pi r. कितना घुमा we can know from this. Okay. Sure. No. Now relation between angular velocity and linear velocity, which we know already, v equal to r omega. But v equal to r omega, very important one, v equal to r omega is only true for circular motion. सर्कुलर मोशन में डायरेक्टली हम लोग बोलेगा v इक्वल टू r ओमेगा r ओमेगा ओमेगा. देखो वेलोसिटी एवरी टाइम में देखो, इफ यू सी केयरफुली द रेडियस एंड वेलोसिटी आर ऑलवेज परपेंडिकुलर. velocity and radius is always perpendicular. That's why simply we can write V equal to R omega. But whether omega will be only in circular motion or straight line motion also omega will be there. Tell me. Omega will be there only in circular motion or straight line motion also will be there.
But only circular motion.
No. Straight line motion also will be there. मान लो I am the observer. Here one particle P is there. Okay. The particle is going with velocity V. It is going constant velocity. It is going with constant velocity. As the observer, my eyes will be changing like this, like this, like this. मतलब मेरा angle घूम रहा है, angular displacement is happening. When the particle is going that direction, my angular displacement is also happening. Whenever there is angular displacement, angular velocity will be there. Okay. So in a straight line motion, may also omega will be coming. At that time, from this we cannot say omega is V by R. So formula कौन सा use करेंगे? Formula is omega is equal to V perpendicular by R we have to use. This is true for any case. Even circular motion also. V perpendicular इधर क्यों नहीं लिख रहे? Because we know already perpendicular to the radius. That's why we are not writing this one. So anybody says in the class में V equal to R omega means नहीं वो नहीं आपको correct करना पड़ेगा. Omega is equal to V perpendicular by R is the formula. Okay.
Yeah.
चलो. इसका बेस में क्वेश्चन. And omega generally always with respect to one respect में point के respect में always we have to calculate. Omega will be changing with respect to observers. Okay. उसके respect में we have to calculate. Okay. So क्या है? Omega is angular velocity, tangential velocity we should take, and R is the radius vector of the path. No need of writing, we know already. Okay. Only the perpendicular component of velocity contributes to the angular velocity. Very important. Only the perpendicular component of the velocity will contribute the angular velocity. So we say formula we should write V perpendicular equal to R omega is equal to V perpendicular by R. So a particle moving with a constant velocity will have angular velocity also. So till now we are learning the second parameter. Angular velocity का कहानी चल रहा है पूरा. Done? न्यूमेरिकल्स ऑन देयर रिलेटिव एंगुलर वेलोसिटी के बारे में लर्न करेंगे. ओके. देखो ये करो. A particle is moving with constant speed in a circle as shown in figure. देखो पार्टिकल वेलोसिटी से जा रहा है, इधर से वेलोसिटी v जा रहा है, ऐसा कांस्टेंट वेलोसिटी से जा रहा है, घूम रहा है, रेडियस r है. ओके. इधर पॉइंट b है, दिस इज द पॉइंट b एंड डिस्टेंस बिटवीन देम इज r डिस्टेंस दूर में, वन मोर पॉइंट इज देयर c. ओके. वन मोर पॉइंट इज c. Find the angular velocity of the particle A. A का angular velocity चाहिए with respect to B and C. मतलब I want to find omega of B, omega of A with respect to B, and omega of A with respect to C is how much? He has given angular velocity with respect to O is omega. Omega of A with respect to O is, he told omega. Okay. So देखो particle A with respect to O. What is the formula? Tell me. Omega A O is nothing but V perpendicular by R. V perpendicular by R. V perpendicular is how much? V only in this case में. V by R is R only. This one we got from this data में. Omega V by R. Now tell me what is omega of B, omega of A with respect to B. Tell me distance कितना होगा? R vector is how much? We have to use always this one. V perpendicular by R. So V perpendicular is V only. By R is how much distance from that is 2R. And V by R is nothing but omega. V by R is nothing but omega. So omega by 2. We got. समझ No calculator इसका. With respect to A, मतलब omega of A with respect to C. C के respect में उसका speed कितना है? Tell me.
So it'll be omega by 2, minus omega by 2, I think.
V perpendicular by R. V पर according to the C, A का particle कितना है? Okay, velocity कितना है? V only. V perpendicular, right? So V by R is how much from initial point to the final point का distance? 3R. So V by R is equal to omega.
Omega by 3.
देखो from this you can understand that particle observer का respect में omega will change. Same particle only, but different observer का different angular velocity will be there. So circular motion में even though it is moving with constant velocity, omega is changing. Since understood, right? Why it is changing? बोल के we saw this one. Okay. I करो. Now B is not at rest. Before the observers are rest. Now B is moving. Relative velocity V perpendicular means V relative लेने का. करो कितना है? Find the angular velocity of the particle A with respect to B. Angular velocity, right? Omega of A with respect to B. If the angular velocity of A with respect to O is omega, that is about V by R. Now here observer O is at rest, that's why simply V by R. Now इधर क्या यूज करेंगे? Since both particles are
2 omega.
2 omega, no wrong. V relative perpendicular
Omega by 2 only.
by R. कितना?
Omega by 2.
No wrong. देखो relative velocity में आपको changing velocity, right? देखो what is the formula? Tell me. VAB याद है formula? Normally
VA
VAB
minus
formula,
VB.
VA minus VB. Omega AB means omega A minus omega B. This is positive, this is negative, right? So minus of minus will be how much? Become plus हो जाएगा.
Yes.
So 2V हो जाएगा. समझ में आ रहा है? V omega A is V minus omega B. Omega B is in downward direction minus V. By R is from here to here. How much?
2R.
2R. So it is
So V by R.
2
Oh, it's just
V
omega
by
only.
2R omega. So where relative velocity is VA minus VB. See before problem में क्या था? Observer is at rest. That's why we are not taking this. Otherwise relative लेना पड़ेगा. So angular velocity का कहानी understand करो is बहुत important है. चले करो. Now O is at fixed position. The particle is here initially. It is going with constant velocity V. He is asking find the angular velocity of A with respect to O at an instant shown. इधर जब इधर था ना इसके इस
So
time में
from O to A, like there's no velocity, like for the previous question. Like if we go to the previous question, they show the velocity of B and A, right?
B का velocity is downwards and A का velocity is upwards.
Yeah, but in the next question, there's no velocity upwards, right? There's only one velocity.
O is at rest. Directly A line लेगा.
So then we get minus V by 2D.
Omega A with respect to O is how much?
So when we get minus V by 2D,
Minus V by 2D. Why?
oh, displacement. Never mind.
Angular velocity.
Minus V by root 2D.
देखेंगे.
Sir, isn't this like the distance of closest approach?
नहीं डिस्टेंस ऑफ क्लोज अप्रोच नहीं है. देखो I told right मेरा सीधा में particle is there. Initially particle is here. When the particle is going with constant velocity, मैं change करता जाऊंगा observer. Angular velocity is changing. Angular displacement is changing. Angular velocity will be there, right? Now क्या है R vector from here to here we have to join is R vector. ये कितना होगा tell me?
V by 2D.
V by 2D.
2D.
Yes, perfect. देखो ये distance is how much? 90 degrees है ना? So कितना? root 2D. Okay. Now R से what is the formula we have to use? V perpendicular by R. R से perpendicular रहने का. R vector से perpendicular velocity लेने का. We should not take this one, right? This perpendicular velocity we should take. R से perpendicular velocity we should take, right? That velocity we have to find. उसके लिए you have to understand this is दोनों same D है ना, so this is 45, this is 45, so this angle is how much?
45.
45. So what is the component of V along this direction is V cos 45. So it is V by root 2. So
Oh,
therefore,
V by root 2.
V
Okay,
perpendicular
got it.
by root 2 by root 2D.
So V by 2D. Yeah.
V by 2D is answer. ये important है. Understood?
Yeah, got it.
Yes, sir.
Yes. Next third parameter, time period. This is easy, which we already know. Time period means circular motion के terms में बोलने का. The time taken by the
time
object to
taken by
complete
the object to finish a
complete
revolution.
one revolution. एक चक्कर घूमने के लिए कितना टाइम लगा? That is the time period.
So time period and time are different, right?
Same only. Time period, time.
So, sir,
Time period is nothing. See it. Instantaneous में time that is different. But general time period means time taken to complete one revolution.
so when we use that formula, like S is equal to half AT square, and that T is time period.
That is time. No, not time period. Time only. At the time में what is the displacement हुआ बोल के. This time period is circular motion में complete one revolution होने के लिए कितना time है? That is called time period. Okay. Covered. Next, fourth parameter is frequency. Frequency को we represent as F. What is frequency means?
1 by time period.
Okay, but what is
The
frequency?
number of
Revolutions
oscillations
per
per
second.
minute.
Number of complete revolutions of a particle in 1 second. 1 second में कितना complete revolution करेगा? That is called frequency. Suppose मान लो in one revolution में the particle has in t seconds में cover किया. Particle one revolution took some seconds. It may be 3, 4, 5 seconds. Okay. I want frequency आने के लिए 1 second का चाहिए. 1 second का कितना revolutions? How to find? 1 by t. Right? By unitary method किया तो 1 by t आएगा. And this is nothing but frequency. So therefore frequency का formula है F equal to 1 by t. Number of revolutions per second. So आपको sometimes they'll give in minutes. आपको convert करना पड़ेगा into seconds. Okay. Chalo. Now other one is angular frequency. We represent as omega. Kinematics में these are variables we have to know. So the number of radians an object covered per second. मतलब कितना radians घुमा है? 2 pi, 3 pi, 4 pi of total radians कितना घुमा है in per second while moving around the circle is called as angular frequency. Okay. So angular frequency का relationship क्या है? We know that omega equal to 2 pi f. And f equal 1 by t. I can write like this also. 2 pi by t is the formula. Right? This is the angular frequency का formula.
So this over here, this omega is the angular velocity.
Angular frequency.
Frequency, sorry.
Angular frequency. In terms of frequency में दिया था angular frequency. और दोनों same
Sir,
लगाया.
if they give frequency in terms of minutes, how do you convert it to seconds?
हाँ by 60 करने का.
Oh, that's it.
F is equal to suppose 300 revolutions per minute. तो आपको by 60 किया तो it is 50 revolutions per second.
So by 60 is 5, sir.
Huh?
If
Oh,
you
sorry,
do it by 60 is 5.
5 only, right?
That's not
Oh,
50.
sorry, yeah. So per but divided by 60 करने का. Okay. These are formulas. These are kinematics में वाला. One more thing we have to know. That is, I करो first. These are JEE mains questions only.
So there isn't linear speed, not, oh, never mind, nothing.
Oh yeah, anything, all mixing together they're doing. An insect trapped in a circular groove of radius is given, moves in a groove steadily and completes 8 revolutions in 96 seconds. From that we can find frequency also, and from that we can find linear speed.
So there's a linear speed, nothing but just distance by time.
No, check karo, we done till now all the variables, right?
What is
Linear
linear speed?
we have to find v.
Oh, okay.
From this frequency aa jayega. From that omega also you can find, right? Omega we can find from this after getting the frequency.
Sir, should we write the, sir, should we get the answer in, we'll get the answer in pi, right?
Not pi.
Yeah, like we'll get some pi value.
I'll give options. 8.6, 5.4, all centimeters per second. 6.2, 7.8, all are centimeters per second.
Oh, centimeter per second. Okay.
Yeah.
So 5.4.
5.4 देखेंगे. Linear speed is v.
Sir, I have a doubt. Sir, I got the W, like the angular frequency as.
देखो v equal r omega you can find, right? R omega.
Yeah, that's what I did.
And frequency is how much? 8
12.
revolutions.
12.
1 by 12 or 12?
So 12.
8 revolutions, 96 seconds. 1 second में कितना revolutions है?
1 by 12.
12.
So it is 8 by 96, right? 1 by 12.
Mm.
It is nothing but frequency, right?
Oh my God. Oh
No,
my God.
frequency is 2 pi f. No, frequency omega is 2 pi f, right? You so
So it
Yeah,
could
it's
be
like pi by 6.
how much you got, Krishna?
Sir, I'm getting the wrong answer.
आप बोलो मैं right wrong बोलता हूँ. How much?
Sir, I'm getting 10 point something.
No, wrong answer.
Sir, I know that it's wrong, sir.
So 1 second, using calculator. Huh? I'm getting 7.8.
हाँ 7.8 is answer.
Oh.
देखो r is 15 into omega is 2 pi f, right? 2 pi f is 1 by 12. खत्म. 2 6 is 12.
Yeah, I
3
get
5
3.
is 15.
That's
3 is 6.
5 pi by 2.
That is 5 into 3. If you take 3 approximately, 15 by 2 is 7 point change is this one, right? 7.8 is answer. देखो linear and angular का
Where
r
are
बीच
the
में
dot?
आएगा. Tell me, Ravana.
Sir, I got. Oh, it's v square. Oh.
7.8
Sir,
is.
one sec.
Sir. Sir,
Yeah.
I can't understand where I went wrong.
See, ये समझ में v equal r omega. R is
Sir,
how much?
it's the same thing. But then
Ah.
instead of taking 2 pi into 1 by 12, I took 2 into 27 by 22 by 7 into 1 by 12. And then it will become 11 by 21.
Instead of pi, you took 22 by 7. That's it. Huh?
Yeah, in the start, I calculated W separately and I
हाँ
got 11/21.
ठीक है, वो कैलकुलेटर से यूज करो, समझ में आएगा कैलकुलेटर किधर की मिस्टेक किया बोल के. ओके, v इक्वल अंडरस्टूड एट लीनियर स्पीड ऑफ द इंसेक्ट इज. ओके ओके, ये भी करेंगे. एंगुलर एक्सेलरेशन लिख लो. एंगुलर एक्सेलरेशन लास्ट पैरामीटर, राइट? एंगुलर एक्सेलरेशन. सो अल्फा, अल्फा के बारे में व्हाट आर थिंग्स यू नो? ए के बारे में यू नो, राइट? सेम थिंग, अल्फा ओनली. Rate of change of velocity is called acceleration. This is rate of change of angular velocity is called angular acceleration, right? So likho, it's the time rate of change of angular velocity of a particle is called as angular acceleration. Okay, now this you know radians per second square, and dimensions is t power -2, right? T power -2 is the dimensions. And ए भी वेक्टर क्वांटिटी है. एंड एंगुलर वेलोसिटी कौन सा डायरेक्शन में होगा? वही डायरेक्शन में एंगुलर एक्सेलरेशन आल्सो विल बी इन द सेम डायरेक्शन. सेम फॉर्मूला लीनियर का कैसा किया पूरा अभी तक जो भी किया सेम सर्कुलर मोशन में आपको घुमा के करना पड़ेगा. नो अदर थिंग्स. जैसे वर्कशीट में आपको ज्यादा क्वेश्चन आर देयर, उसमें करो ज्यादा क्वेश्चन. आंसर्स आल्सो, डिटेल आंसर्स आल्सो गिवन इन दैट वर्कशीट में. So try to do each and every question. Okay. Next. Okay. Average angular acceleration. We have two different types of angular acceleration, right? Average and instantaneous. Average क्या है? Alpha average is delta omega by delta t. We know this one, right? A average का फॉर्मूला क्या होगा? Delta v by delta t. Same thing. And similarly, instantaneous का d omega by dt. A instantaneous will be dv by dt. ओके, सो सपोज मान लो ओमेगा इज इक्वल टू आपको टी क्यूब प्लस 5. टेल मी आई वांट अल्फा इन 0 to 2 seconds and alpha at 2 seconds. फाइन करो. आई वांट अल्फा 0 to 2 seconds, मतलब बट एवरेज अल्फा एवरेज. फाइन करो.
So 0 to 2 means we should put.
देखो
So at 2 seconds, you have to differentiate and put W equal to 2.
देखो दिस इज एट 2 seconds मींस इंस्टेंटेनियस.
Yeah.
एट द टाइम टाइम इक्वल डिफरेंशिएट करने के बाद t इक्वल 2 लगाने का. ओके, इधर क्या है? व्हाट इज द फार्मूला अल्फा का, एवरेज का फार्मूला?
Should we just first differentiate it, then substitute 0, substitute 2 and add both?
नहीं, don't differentiate. 0 to 2 seconds means alpha average is asking. Alpha average in 0 to 2 seconds पे. So how to find alpha average formula क्या है? Omega delta omega by delta t is the formula, right?
Would it be 4? It'll be 8. Like if you substitute, you'll get 5, and if you substitute, you'll get 13. So 13 minus
omega
5/2.
क्या करना है? Omega in 2 seconds minus omega in 0 seconds by t2 minus t1. 2 minus 0 is 2. Now पहले ओमेगा में 2 सब्स्ट करो एंड देन ओमेगा में 0 सब्स्ट करो, और टी के जगह में 0 सब्स्ट करो, देन समझ में आएगा आपको. ओके, सो कितना होगा? ओमेगा इन 2 मींस 2 क्यूब इज सो मच 8. 8 plus 5 is 13 ना? 13.
Yeah.
माइनस ओमेगा 0 मींस टी के जगह में 0 लगाओ, 5/2. So it is 8/2 is 4 meters per second square. Right? Understood formula? ये यूज कर रहे formula. Average की velocity का we done, right? v2 minus v1, v final minus v initial by time. Same thing. How many seconds? ये find करो. Alpha instantaneous find करो. At 2 seconds means?
12.
Yes, 12. Because alpha is equal to d omega by dt. So differentiate किया तो 3t square. So 3 into 2 square is 4, 12
Yeah,
meters
got
per
it.
second square. नाउ इसका फॉर्मूलाज पूरा सेम ओनली काइनेमेटिक्स में, इसका टाइम वेस्ट ज्यादा नहीं करने का। लाइक यू नो व्हेन द एंगुलर वेलोसिटी इज गिवन, हाउ टू फाइंड एक्सेलरेशन मींस आपको आगे अगर स्लोप फाइंड करने का, पीछे है तो एरिया फाइंड करना, इंटीग्रेशन करना पड़ेगा। तो ऑल फॉर्मूलाज एक जगह में लिखने वाले हैं। ओके, वो हम लोग नेक्स्ट क्लास में करेंगे, वो पूरा करके देन दैट नेक्स्ट क्लास में वी विल ट्राई टू फिनिश द कंप्लीट काइनेमेटिक्स ऑफ सर्कुलर मोशन।